Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today we will explore conservation strategies for fragmented landscapes and why this topic is central to modern conservation biology. Habitat fragmentation occurs when large continuous areas of habitat are divided into smaller isolated patches by roads, agriculture, urban development, or other land uses. This process reduces patch size, increases isolation, and changes the surrounding matrix. Those three changes alter ecological processes, from population dynamics to nutrient cycling. To understand the implications, we can use metapopulation theory. A metapopulation is a set of local populations that inhabit discrete patches and are connected by dispersal. Local extinctions can be balanced by recolonization from other patches. A classic empirical example is the bay checker spot butterfly in California, where local extinctions and recolonizations have been observed across fragmented grassland patches. Fragmentation also produces edge effects. Edges experience altered microclimate, with increased light, wind, and temperature fluctuations. These conditions favor invasive species and increase nest predation for interior forest birds. Edge effects therefore reduce the amount of core habitat available for species that require stable interior conditions. Genetic consequences are another major concern. Small, isolated populations lose genetic diversity because of drift and inbreeding. A management response to this problem is genetic rescue. For example, managers introduced pumas from Texas to supplement the Florida panther population. That translocation increased genetic diversity and improved fitness indicators in the panther population. When we design reserves and restoration actions, we confront the SLOS debate. That stands for single large or several small reserves. Single large reserves benefit wide-ranging and area-sensitive species by reducing extinction risk and preserving interior habitat. Several small reserves may capture a wider variety of habitats and thus protect more species when communities are heterogeneous. So the choice between single large and several small is not a one-size-fits-all answer. It depends on species' life histories, the spatial configuration of habitat, and the nature of the surrounding landscape. To improve connectivity, we use habitat corridors and stepping stones. Corridors are linear strips of habitat that link isolated patches. Stepping stones are smaller habitat nodes that allow gradual movement. Costa Rica has developed biological corridors to connect forest reserves, while the European Greenbelt functions as a large transnational corridor along a former political boundary. However, habitat corridors are not a panacea. They can increase gene flow and recolonization, but they can also facilitate the spread of disease and invasive species, or expose animals to greater mortality if corridors cross roads or human-dominated areas. Beyond corridors, we must consider the matrix, the non-habitat areas between patches. Managing the matrix to be more permeable to movement, for example through agroecological practices or reduced pesticide use, can greatly enhance functional connectivity without formally designating corridors. Practical conservation requires an integrated approach. Combine protected areas with restored corridors, buffer zones to reduce edge impacts, and policies that incentivize private landowners to maintain habitat elements. Payments for ecosystem services in Costa Rica are a good example of incentivizing landowners to participate in landscape-level conservation. Monitoring and adaptive management complete the cycle. Use demographic studies, genetic monitoring, and movement tracking to evaluate whether connectivity interventions reduce local extinction rates and maintain genetic diversity. If not, modify management actions. In summary, fragmented landscapes present complex challenges. Metapopulation dynamics, edge effects, genetic isolation, and the quality of the matrix all matter. Effective conservation blends reserve design, connectivity measures, and landscape-scale policies, while remaining aware of potential unintended consequences. Next session, we will look more closely at quantitative tools to model connectivity and prioritize patches for conservation investment. For now, consider how these concepts apply to a landscape you know, and whether corridors or larger reserves would be the best strategy there.
Listen again to part of the lecture, then answer the question.
Habitat corridors are not a panacea. They can increase gene flow and recolonization, but they can also facilitate the spread of disease and invasive species.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.